These periodic trends weren't discovered too long ago. They're extremely helpful though. Uh-oh. The periodic table is filled with trends that you should know. Down a group they sometimes go, left to right in a row. Periodic trends, baby! First, let's talk about effective nuclear charge. It's based on the attraction between protons and electrons. It increases as you go from left to right in a period. Because of the higher proton to electron ratio, the protons pull the electrons closer to the nucleus. This makes elements on the right side have a smaller radius. Down a group, the electrons are further from the nucleus. Plus, these elements will have a greater atomic radius.
And metallic character.
This trend can also be applied to every ion. Here, the radius depends on class of electrons. An atom's radius increases when it comes to anion. Conversely, decreases when atoms convert to cation. These periodic trends weren't discovered too long ago. They're extremely helpful though. Uh-oh. The periodic table is filled with trends that you should know. Down a group they sometimes go, left to right in every row. Oh, 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 row. Oh, or sometimes diagonal. Oh, oh, oh. We still have more to cover though. Let's go! The next trend up is ionization energy. It's the energy it takes to remove an electron. You see, it increases left to right across the period because the electrons are more strongly attracted to the nucleus. However, decreases as you go down a group because the electrons are further away from the nucleus.
This is called the shielding
This
effect.
energy increases as you remove more than one electron. There's a second, third, fourth, fifth, and so on. For example, when you take an electron sodium, it has a complete octet, so now it's quite stable. It takes a huge amount of energy to remove another one. Thus, the second ionization energy is a ton. These periodic trends weren't discovered too long ago. They're extremely helpful though. Uh-oh. The periodic table is filled with trends that you should know. Down a group they sometimes go, left to right in every row. Oh, 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 row. Oh, or sometimes diagonal. Oh, oh, oh. We still have more to cover though, but then there's always exceptions to the rules, yeah. If you forget them, you will look like a fool, yeah. Nitrogen's ionization energy is greater than O's because it has a half-filled p orbit, oh yeah. These periodic trends weren't discovered too long ago. They're extremely helpful though. Uh-oh. The periodic table is filled with trends that you should know. Down a group they sometimes go, left to right in every row. Oh, 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 row. Oh, or sometimes diagonal. Oh, oh, oh. We still have more to cover though. I know we must talk about electronegativity. It's a measure of an element's electron gain tendency. From left to right, electronegativity increases.
And so does non-metallic
because
character.
the number of valence electrons increases, making it more likely for an electron to be accepted. Thus, fluorine is the most electronegative element. Down a group, electronegativity decreases because the valence electrons are further away from the nucleus. The electron affinity works pretty much the same way. It's the negative of the energy when electrons gain. It decreases down a group and increases left to right. But just know that chlorine's electron affinity is the highest. These periodic trends weren't discovered too long ago. They're extremely helpful though. Uh-oh. The periodic table is filled with trends that you should know. Down a group they sometimes go, left to right in every row. Oh, 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 row. Oh, or sometimes diagonal. Oh, oh, oh. Hopefully now you are a pro.